In this video, we're going to talk about exercise 4.3, question 15. So first of all, let's read the questions. So we have L1, that is x minus 3y minus 30, and L2, that intersect at P. So you can draw two straight lines. You don't need to draw it exactly the same. Just to illustrate, let's say this is L1, this is L2. So this is going to be the intersection point P. So first of all, you need to find the coordinates of P, which means I need to find the intersection between the L1 and L2. So first of all, we can just write it into the simultaneous equations in two unknown. So I have x minus 3y equal to 30, and I have 2x plus y equal to 4. So I change a little bit with the general form. I move the negative 30 to the right becomes positive, move the negative 4 to the right becomes positive 4. Then we can just use our program 1. So program 1 to get that the 1, negative 3, 30, and 2, 1, 4. To get our answer, that's going to be x equal to 6, y equal to negative 8. So if you still haven't got a program, come and ask me to take it. Okay? So that's going to be the value of the coordinates P. So for the second part, we need to find the distance between the origin and P. So the meaning of the origin is going to be this point. This is the OO. I'm going to draw it again. So this point is going to be our origin. And the coordinates for the origin is going to be 0, 0. And let's say this is our point P, 6, negative 8. And no, it's not in scale. It's just an illustration. So we're trying to find the distance here. The yellow highlight part is going to be our distance to be found. Then we can use our distance formula, if you still remember that. So the distance formula told me that the r is equal to the x2 minus x1 squared, the difference between the x and then plus y2 minus y1 squared, the difference of y, and then we take the square root. This actually means by the Pythagoras theorem. Then now we can try to substitute all of the numbers into here. So now we have the r should be equal to 6 minus 0 squared. So x2 minus x1 squared, and then plus y2 minus y1. So y2 minus y1, and I take the squared, then I take the square root. So r should be equal to 6 minus 0 giving you 6, squared giving you 36. Similarly for this one, negative 8 minus 0, this should be minus, and then that's 8, and 8 squared giving you 64. Then I take the square root giving you 10. So that's for question 15. The main thing to be remembered is, if you're trying to find coordination of the intersection, you should set them into a simultaneous equation, then you can just use a program 1. But the first thing is, you need to change it becomes the left part. The left part is going to be all of the variables, and the right part is going to be the numbers. Okay? So now you still need to remember the distance formula. That's the change of x squared plus the change of y squared giving you r squared. But you don't want it squared, so moving to the right becomes the square root.